Question 7, which is a past year question. A slide projector is required to produce a real image with height 684mm of an object 36mm high. If the distance of the object from the screen is 2 meter, calculate the distance of the lens from the object. So this is asking for U. And then lastly, the focal length of the lens lah. Okay, so for this question, we do need to know what does a slide projector produce. So a slide projector would produce a real, inverted, and magnified object. Okay, so based on this, we will then know what needs to be negative and what needs to be positive. Okay, so if the image is inverted, the height of the image will be a negative value. So it will be negative 684 millimeter lah. And then since the image is real, our V here should be a should be a positive value lah. Meaning our what do we need to write is it should have a modulus so that it will stay positive lah. Okay, right, lepas tu we are looking for U, which is the object distance, which should be real, so this should also have a modulus. Okay, right, so the height of the object, it's just 36 meter lah. Okay, so what do we do first is we're gonna start with the magnification punya formula. Okay, so the magnification punya formula is hi over h naught equal to negative v over u. So let's just substitute all the values. It's going to be negative 684 divided by 36 equal to, so we are going to do modulus juga later. So over, it should be positive. These two should always be positive. Okay, so 684 divided by 36, you will get negative 19, which is then equal to this value here. Okay, so let V become the subject, and then this is gonna be basically the negative will cancel each other, and then you'll get something that's like this. Okay, so the modulus is there just to let you know that it should always be positive lah. Okay, so we know that the question mentioned that the distance of the object from the screen is 2 meter. So if the object is here and the screen is here, this distance is 2 meter. Meaning that from the, what lens is this? Oh, what lens is a projector? Did it mention that? I am not sure. What is the lens for slide projector? Oh, okay, so it has a lot of lens, but it is a convex lens. Dia tulis sini dia convex lens. So if it's a convex lens, it is gonna be somewhere here lah. Okay, convex lens, it's gonna be somewhere there. So basically what I'm trying to do is telling you that this distance of the object and the what do we call that, the image distance should equal to 2 meter lah. Okay, so contohnya di sini adalah distance U, and then di sini adalah distance V. So this here will be equal to 2 meter lah. So what I'm trying to write here is basically U plus dengan the image distance would be equal to 2. Dia tidak boleh lebih dari 2 meter sebab dia punya distance from the object and the screen is just 2 meter. Right, so kita dapat dua equation di sini. So what we can do is we can substitute. Can I write this as 1 and this is 2? Substitute equation 1 here into equation 2. So we will then write it as 19u equal to 2. So this will be equal to sorry, the blue 20u equal to 2, which is telling us that the what is it, the the object's distance. Okay, so the object's distance is then equal to 0. Wait, let me just do 2 divided by 20. So the object distance is equal to 0.1 meter. Okay, so hopefully you are not that confused, but if it was me as a student, I would be confused because I do not know anything about slide projector. So basically, a slide projector would produce an image that is real, inverted, and magnified. So based on this characteristic here, we know that the height of the image will be a negative value since it is an inverted image. And then based on that, we just have to know that the image should be real, so the image should be positive and object will always be positive lah. Okay, because it is in front of the lens here, and then it's telling us the distance of the object from this to the screen here is 2 meter, meaning that the total object distance plus the image distance would be equal to 2 meter, not greater than 2 meter. Okay, so from that, just use the magnification values just for us to find an equation like this. Okay, after that, you can just then substitute into this formula here, into that expression there, and then you will get the object distance. So remember, it should be real, so it's going to be positive lah. Okay, next we're going to calculate the focal length. So the focal length we are just going to do as using the formula 1 over f equal to 1 over u plus 1 over v. Okay, so we are looking for we are looking for f. We already have u, we just do not have the value of v. So how do we find v? We are going to use equation 1, which is 19 u equal to 19 modulus u. V is equal to 19 modulus u. So this is that. So you just have to substitute 0.1 here, so you'll get the image to be equal to 1.9 centimeter lah. Is it centimeter or meter? It should be meter. Is it meter? Okay, meter, sebab kita sudah this millimeter here kena cancel, and then 2 meter. Okay, so we are using meter now. So from there, you just have to substitute into this equation here. So this is 0.1 plus 1 over 1.9, telling you that the focal length, it's going to be equal to 0.095 meter. Okay, so that is the focal length for this question. And that is all for question number 7.